All right, I'm going to be starting up again on the Chapter 5 test review, and I'm starting at number 15. So from 15 to 18, we're going to be finding the inverse of each function. So if you look on your worksheet on inverse functions, you'll see the 4 steps that we have to follow to solve an inverse, or to find the inverse of a function. And I will list off the steps. So step 1 is to change f of x to y. Step 2 is to interchange x and y, meaning that you're going to switch their positions on the equation. Step 3 is to solve for y. And then once you solve for y, the fourth and final step is going to be to change y to the inverse of f of x. So we're going to use those 4 steps to solve these next 4 questions. Now, number 15 is pretty simple. So for number 15, we have h of x is equal to x minus 4. So step 1, we're going to change h of x to y, right? Then step 2 tells us to interchange x and y, meaning they're going to switch positions on the equation. So our equation is y equals x minus 4, and when we interchange x and y, it becomes x is equal to y minus 4. Right? These just switched positions. Now the next step is to solve for y. Now, in order for me to solve for y, I have to get rid of this minus 4. To get rid of the minus 4, I'm going to add 4 to both sides, and I get x plus 4 is equal to y. And now I finished solving for y, so I have to just change y to the inverse of f of x, or of h of x is what we have here. So we write the inverse of h of x by doing h with an exponent of -1 of x. So now I'm going to rewrite this with the inverse of h of x at the front. So the inverse of h of x is equal to x plus 4, which is option B. So number 15 is pretty simple. All right, so number 16, we're going to follow the same 4 steps to find the inverse of that function. And now on this one, there is one step that is a little bit complicated. I'll explain it once we get there. So I want you guys to pay attention to this and make sure you know how to do this. So for number 16, we have g of x is equal to -3 over x plus 1 plus 3. So step 1, we're changing g of x to y. Step 2, we're going to interchange x and y, right? So our equation becomes x is equal to -3 over y plus 1 plus 3, right? We switch the positions of x and y. So now the final, or not the final step, but the third step is to solve for y. This is the tricky part, right? So we got to get y by itself. So what we're going to do first is we need to get rid of this plus 3. We're going to do that by subtracting 3 from both sides, right? So now I have x minus 3 is equal to -3 over y plus 1, right? So now we have x minus 3 is equal to -3 over y plus 1, and y plus 1 is in the denominator, right? So we want everything to, we don't want any fractions here, right? So in order for us to get rid of a denominator, we have to multiply by the denominator, right? In a fraction, if you want to get rid of the denominator, multiply by the denominator. I've shown you guys this in class before. We've done a few very oversimplified examples of this. Remember the 3 over 4, or 3 divided by 3 over 4. And you know, I did that to prove to you guys, to get rid of the denominator, you multiply by the denominator. So that means that we're going to multiply this by y plus 1 so we can get rid of this denominator, right? And whatever I do to one side of the equation, I have to do to the other side as well. So I'm multiplying both sides of the equation by y plus 1. So what happens here on this side, this gets rid of the denominator, and we're left with just -3, right? So now here is the part where there may be a little bit of confusion, but if you pay attention, this should make sense. So normally, we have 2 binomials being multiplied together, right? We have y plus 1 times x minus 3. So normally we would just FOIL and distribute, right? But we're going to have an issue if we do that, because we're going to have y times x, which is yx. We're solving for y, so having this just makes it so much more complicated. So there is an easier way, and I hope that some of you guys were able to figure this out. But what we're going to do is think of it like this. This is a binomial and this is a binomial, and they're binded together by multiplication, right? Whenever you have a term that you're trying to get rid of in a equation that is binded to another term by multiplication, you divide by that term, right? So I want to get rid of this x minus 3 here because I want y by itself. So in order for me to get rid of this x minus 3, I'm going to divide both sides by x minus 3, right? First, I'm gonna rewrite what I have left over right now. So I have y plus 1 times x minus 3 is equal to, on this right side, I got rid of the denominator here. So I was just left with minus 3, right? So minus 3. And so like I was saying, in order for me to get rid of this term, I have to divide both sides of the equation by this term, right? Because when I divide both sides by x minus 3, it's going to get rid of this, and I'm going to have y. I'm going to be closer to having y by itself. So let's go ahead and do that. So I'm dividing both sides by x minus 3. And here, x minus 3 divided by x minus 3 is just 1, right? 1 over 1, which would be y plus 1 times 1, which is just y plus 1. And then divided by 1, and y plus 1 divided by 1 is just y plus 1. So I'm left with y plus 1 is equal to negative 3 over x minus 3. And then the last thing I have to do to get y by itself, I'm going to get rid of this plus 1 by subtracting both sides by 1, right? And my final solution for y is going to be y equals negative 3 over x minus 3 minus 1. And the last thing that we're going to be doing is changing y to the inverse of g of x. So we get the inverse of g of x is equal to negative 3 over x minus 3 minus 1. So if we look at our options, there isn't an option that looks exactly like this, right? But there is an option that is equivalent to this. The only thing that they're doing is they're applying this negative sign to the denominator. Whenever you have a negative fraction, you can apply that negative sign to either the numerator or the denominator, right? In order to keep it a negative. They didn't apply it to the 3, so that means that because there's only one option here that has a 3, which is option B. But if you apply that negative sign there, you get the inverse of g of x is equal to 3 over, and then when you apply the negative to this denominator, all the signs change, right? So x becomes negative x, and minus 3 becomes plus 3 minus 1, which looks exactly like option B. Our answer is option B. So again, this step right here was a little confusing. We're going to be seeing that again in number 18. So if you want to see another example, just make sure to pay attention to number 18. I'm going to erase this so I can have space whenever I write number 18. All right, number 17. So again, we're going to be solving or finding the inverse of a function, and we're going to follow the same 4 steps. Don't get intimidated by this fifth root. We'll get to that. But all right, step 1, we're going to change g of x to y. Then step 2, we're going to interchange x and y, right? So the new function that we have becomes x is equal to negative y plus 2. Oh, it's actually the 5th root. So x is equal to the 5th root of negative y plus 2 over 2. Let me write a better 5. So x equals the 5th root of negative y plus 2 over 2. So now we're solving for y. So the first thing we have to do is we got to get rid of this radical, right? And the way that we're going to get rid of the radical is we're going to raise both sides to the power of the index, right? So the index is 5. I'm raising both sides to the 5th power. And this gets rid of the radical, right? You should remember this from our radicals lesson or solving radical equations. When we were solving radical equations, we did something similar to this. So x to the 5th power just becomes x to the 5th power, right? We have x to the 5th power is equal to negative y plus 2 over 2. We just got rid of the radical. Next, we're solving for y still, so we have to get rid of this denominator. Just like we did in that last example, to get rid of the denominator, we're going to multiply by the denominator. And what we do to one side, we have to do to both sides. So we have 2 times x to the 5th power, and over here on this side, they get eliminated. So 2 times x to the 5th power becomes 2x to the 5th power is equal to negative y plus 2. Next, we have to get rid of this plus 2 by subtracting 2 from both sides. So we get 2x to the 5th power is equal to negative y. Let's get rid of each other. And the final step, oh, I forgot to write the minus 2. So we have 2x to the 5th power minus 2 is equal to negative y. And the final step is to get rid of this negative sign in front of y. We're going to do that by dividing both sides by negative 1. So dividing both sides by negative 1 is just going to change the signs, right? So 2x to the 5th power becomes negative 2x to the 5th power. Minus 2 becomes plus 2 is equal to negative y becomes positive y. And the last step is to change y to the inverse of g of x. So our final answer is the inverse of g of x is equal to negative 2x to the 5th power plus 2, which is option B. All right. So then finally we're on number 18 for solving or finding the inverse functions. So for number 18, it's very similar to number 16. So make sure to pay attention to that step if you were a little confused. So step 1 is going to be to change g of x to y. And then step 2, interchange y and x. So our function becomes x is equal to 3 over y minus 1 plus 1, right? We just changed x and y here. Now we need to solve for y, so we have to get rid of everything that's on the same side as y. So first we're going to start off by getting rid of this 1 plus 1 by subtracting 1 from both sides. So I get x minus 1 is equal to, let me give myself a little more space, x minus 1 is equal to 3 over y minus 1. So now again we have the problem where we have a fraction. We don't want any fractions, we want all whole numbers or terms. So we have to get rid of this denominator, right? Again, to get rid of the denominator, you're going to multiply by the denominator. Multiply the fraction by the denominator. So we're multiplying both sides by y minus 1. Right? So we get rid of this here, and then we're left with y minus 1 times x minus 1 is equal to, and we're left over with just 3. So again, if we would follow this normally and distribute, we would get the issue of having yx, which takes us further away from solving for y. So the easiest thing to do, since this term and this term are bounded by multiplication, the easiest thing to do is to get rid of 1 by dividing by that term, right? So I want to get rid of the x minus 1. That's going to help me get closer to getting y by itself. So I'm going to divide both sides by x minus 1. On this side, it gets rid of the x minus 1 in our numerator, right? Because x minus 1 divided by x minus 1 is just 1. We're left over with y minus 1 times 1. So now we have y minus 1 is equal to 3 over x minus 1. And then the final step in solving for y, get rid of this minus 1 by adding both sides by 1, adding 1 to both sides. So then finally, I get y is equal to 3 over x minus 1 plus 1, which is going to be option B. Oh, we didn't change y to the inverse of g of x, so the inverse of g of x is equal to 3 over x minus 1 plus 1, which is option B. So hopefully those didn't confuse you guys. And now we're going to move on to the last three, which is graphing. So when we're graphing, first I'm going to show you guys the way to do it without the graphing calculator, and then for the next two I'm going to do it using the graphing calculator because it's so much easier. So here we have a square root function, right? So before you start, I want you guys to write out the perfect squares. You can, or numbers that you can take the square root of and get whole numbers, right? Because 0, we could start off with 0, right? The square root of 0 is 0. Then the perfect squares are 1, 4, 9, 16. But 16, these are going to be our x values. Not necessarily our x values, but what we want our radicand to be. So they're probably going to be close to our x values. And we're not going to be able to graph 16 because if you notice, the graphs only go to 8 and negative 8. So we don't even need 16. We could just stop at 9. All right. So the reason that I'm writing this out is when I'm making my XY table, I want to have whole numbers, right? Whole numbers are very easy to graph. And in order for us to get whole numbers to graph, we have to make our radicand one of these perfect squares so that when we take the square root of it, we have a whole number, right? So let's start off with what makes our radicand equal to 0. Now, we don't have anything inside of our radicand with x, so we just have to plug in these perfect squares. All right, so when I plug in 0 for x, right, I'm going to start off with my xy table. When I plug in 0 for x, I get the square root of 0, which is 0, plus 5. 0 plus 5 is 5, right? And I can do that real quick just to show you guys visually. So we have the square root of 0, which is 0 plus 5. And that's equal to 5, right? Next, I want the square root of 1 because that's a perfect square. So I'm plugging in 1 for x. I'm going to write that on my x in my xy table. So I'm changing this with 1. The square root of 1 is 1. So we're left with 1 plus 5, which is equal to 6. So when you plug in 1 into this function, you get an output of 6. Next, I'm going to plug in 4. So when I plug in 4 into this function, I get the square root of 4 plus 5. The square root of 4 is 2. 2 plus 5 is 7. Right? Pretty simple so far. And then finally, I'm going to plug in 9 into the function. So I get the square root of 9, which is 3, plus 5. And 3 plus 5 is 8. So when you plug in 9 for x, you get 8. So now I just graph those points. So my first point is at 0, 5, which is right here. My second point is at 1, 6, which is right here. Then after that, we're at 4, 7, which is right here. And then the last point is at 9, 8, which would be right around here. But it's outside of the graph, right? So you just connect the dots, and your graph is going to look something like this. I'm going to make it with more of a curve. And it's simple as that. All right. So for number 20, we're going to, and it doesn't say anything else about the domain or anything. So yeah, we're just graphing each function. All right. So for number 20, we have a cube root this time. So if we want to make an XY table so we know what points to graph. But if you don't have a graphing calculator, what you need to do first is you need to write out the perfect cubes, right? So and we can always start with 0, right? So we want our radicand to equal to 0. We want our radicand to equal to 8. Oh, and 1, right? Can't forget about 1. We can take the cube root of 1. So we want our radicands to be 0, 1, 8, but also the negative forms, right? So negative 1 and negative 8 as well. So if you don't have a graphing calculator to fill in your x, y table, you're going to pick x values that will make your radicand these numbers right here, right? So if you wanted to start with 0, you can go ahead and say, okay, what number do I need to plug in for x to make this equal to 0? Well, if I put in -5, I get -5 plus 5, which is 0. And then the cube root of 0 is 0. Right? So that's how you would do it. Next, you would think, okay, what number do I need to plug in for x to make my radicand equal to 1? Well, to do that, you would have to do -4, right? -4 plus 5 is equal to +1. And then you could take the cube root of 1. Then you would also think, like, what do I need to plug in to make it -1? What do I need to plug into -8? If you said, what do I need to plug in to make it -8? I would say, okay, well, -8 minus 13, which, -8 minus 5, which is -13, because then -13 plus 5 gives me -8. So, now, but however, if you do have a graphing calculator, the easiest way to do this is you're going to take out your graphing calculator, you're going to go to y equals, and you're going to type in the function. So I get y equals -2 plus the cube root of x plus 5. So I'm going to do the cube root of x plus 5. You can graph it. You can graph it to look at what the graph is going to look like. But the best thing to do is to click second and graph, and you're going to go to the table. So you're going to look for all the whole numbers. This we can't graph, right? It's too far out of our graph, so I'm just going to skip that one. Well, actually, I have to graph it because these are all kind of really close to each other. So I'm going to go to my XY table. I'm going to write -3, -13, -4. So -13, -4. Next whole numbers are -6, -3. Then it was -5, -2. Then it's -4, -1. And then we have 3, 0 right here. And the next whole number's not for a while, so the last thing is 3, 0. So you can fill out your XY table very quickly by using the graphing calculator to your advantage. So what you need to do for that is you're gonna go into your y equals, you're gonna type in what the function is, then you wanna click second and graph, which brings you to the XY table, and then you're just gonna look for the whole numbers, right? You want the ordered pairs that have 2 whole numbers because those are easy to graph. It's easier to graph -6, -3 than it is to graph -9, -3.587, and so on, right? So I've already written out my XY table, so I'm going to go ahead and graph these points. I'm going to start off with these centered ones. Well, let's start off here, actually. So we're at 3, 0. That point right here. Then from 3, 0, we go to -4, -1, which is right here. The next point after that is going to be -5, -2, which is right here. The next point, -6, -3, which is right here. And then the final point would be -13, -4. -13 is going to be like somewhere around here. It's going to be like something like that, right? So then we just connect the dots. And our graph is going to look something like that. So, you know, if you didn't want to graph the -13, -14, if you don't want to estimate, you could just do it like this way. It's gonna curve like this and go on forever like that. All right, so I hope that one was easy. This one, I'm just gonna go straight into my XY table. I'm gonna use my graphing calculator to help me out. All right, this has a lot of stuff. So doing all those, taking all those steps and doing all that math is gonna take a while. So I'm just gonna go ahead and graph it. So -2/3 times the square root of x plus 2 plus 2. So -2/3. When you're doing a fraction, you want to type, why isn't this clear? When you're doing a fraction, you want to put it in parentheses. So I had -2/3, right? I'm going to do negative 2 divided by 3 in parentheses. That's the same as negative 2/3, right? So I have negative 2/3 times the square root of x plus 2 plus 2, right? So negative 2/3 times the square root of x plus 2 plus 2. So you can look at the graph. This is what the graph is going to look like. Or you can click second and graph, and that's going to bring you to your XY table. And you're going to look at all your whole numbers. So my first whole number is negative 2, 2. Then after that, I'm going to scroll down. I have 7, 0. And the next whole number is not for a while, not all the way until 34. And I can't graph that. So I just need to graph those 2 points then. Those are the only ones that I can graph. So I'm going to graph them. Negative 2, 2, which is right here. Then 7, 0. So you see this negative causes a reflection across the x-axis. This 2/3 causes a vertical compression. This plus 2 causes our graph to shift left 2 units. And then this causes our graph to shift up 2 units. So we're just going to go ahead and connect the 2 points. So our graph is going to look something like that. And so the main things that I'm looking for on the test is for you to write, because this is not going to be a multiple choice test. Or the test is multiple choice, but these last questions on graphing are not multiple choice. So the main things I'm looking for is the XY table and for the points. If your connection of the graph looks sloppy, if it were like, like that, I don't care, as long as you have the correct points and you have the correct points on your XY table. And so finally, this tells us identify the domain and the range of each. So we have to identify the domain and the range as well. So for my domain, the graphing calculator tells you your domain, right? So negative 2 is the last one that you can get a value for. Everything before that, you get an error. So that means that all your x values have to be, so my x values are greater than or equal to negative 2. The lowest x value you can pick is negative 2. Every x value after that is higher, right? So the lowest x value we have is negative 2, then the negative 1, then 0. And all those numbers are at negative 2 or greater. So that's why we have x is greater than or equal to negative 2. And then finally, for my range, this point tells you your range, right? Because on your range, this is the highest y value that you will ever have, because our graph is going to continue to slope downwards forever, right? So we're never going to get a y value that is higher than this. My y there is 2, so that means that my y is less than or equal to positive 2. So that's your domain and your range. You can look at these two to also give you your domain or your range. And that's only going to apply for a square root function, right? In a cube root, you're going to have all real numbers, because in a cube root function, you could plug in negative numbers and have negative radicands, right? So that's it for number 11, or number 21. If you guys have any questions, please let me know.